Hi, Avi. Welcome back.
Thanks for having me. It's a great pleasure.
It's been a wild journey since I had you on last time. You've been to the Pacific Ocean looking for something. Can you tell us a little bit more about that?
Yeah, so the story starts in January 8th, 2014, when US government satellites detected a fireball from an object that collided with Earth. It's called a meteor, and as it goes through air, the friction generates a lot of heat, and eventually any object that enters the atmosphere uh, explodes, at least in the outside of sometimes some remnant is left. So the government recorded that. It was put in a NASA catalog of fireballs, of meteors. And 5 years later, I was interviewed about a meteor that landed near Kamchatka in the Soviet Union. And in the process of preparing for that interview, I looked at the NASA catalog, and I then realized that, in fact, there may be meteors moving faster than the escape speed from the solar system, meaning that they came from outside the solar system. And indeed, with my student, we found this meteor. It was moving even outside the solar system faster than 95% of all the stars at 60 kilometers per second relative to the local standard of rest. So it was really fast. And moreover, the fireball light curve, the data implied that it was tougher than all space rocks that were cataloged, 272 of them. And so that means that it was even tougher than iron meteorites that make up 1/20th of all the meteors. And that raised the possibility that maybe because it was very fast, it was propelled artificially like a spacecraft, and that would explain why it had material strength tougher than rocks. So just imagine Voyager exiting the solar system and in a billion years colliding with another planet like the Earth. It would burn up as a meteor in the atmosphere of the planet, but would look as if it has a material strength that is an outlier relative to rocks. So to find out, this is not a philosophical question. I decided to lead an expedition to the Pacific Ocean, the location of this fireball, and it was located to within 10 kilometers by the U.S. Department of Defense. And in fact, the U.S. Space Command issued an official letter to NASA confirming the assertion that we made in our paper that it is of interstellar origin. So we were able to narrow the path of this meteor to localize it better than 10 kilometers by using seismometer data from the sound wave that was heard when the explosion took place. Knowing the speed of sound, one can tell the distance from the seismometer. And so we rented a ship, fittingly called Silver Star, and we built a sled that was roughly a meter wide with magnets on both sides, and put it on the ocean floor. The idea is that any droplets that melted off the surface of the object when it was exposed to the immense heat from the fireball must have ended up on the ocean floor underneath. The thing is, this explosion released a few percent of the Hiroshima atomic bomb energy into 500 kilograms of matter. So clearly there was some evaporation, but also melting. And we calculated the droplets should be less than a millimeter in size, very small. The region was 10 kilometers wide, and the depth of the ocean was 2 kilometers. So with a sled of 1 meter just going back and forth, the chance of retrieving those droplets was quite small, and it was a risky project. I was able to recruit 28 people, the best professionals in the world for ocean expeditions, and received the funding at $1.5 million that was necessary. So we went there, and we went over the site of 10 kilometers wide, back and forth for 2 weeks between June 14th and 28th. And in the first day, we couldn't get the sled on the ocean floor because the cable that connected it to the ship lifted it, and it was kiting But eventually, the engineers on the boat managed to go with current in the ocean so that the sled will be on the floor. And then after the second day, we started collecting material. And most of it was volcanic ash, black powder, like you see in this vial, where the results of one of the runs was put. So basically, the magnets collected this magnetic particles sample, and we scraped it from the magnets and put it in vials, and then we used the mesh to filter out the black powder, the tiny particles from volcanic activity. And we ended up with bigger particles than a tenth of a millimeter or so. And amazingly, when we put it under a microscope, we started seeing those marbles, basically spherules, the droplets that melted off the surface of the object. And during the expedition, we found 50 of them from the sample on the ship. And then when I brought it back to Harvard, my summer intern found 650 more. And so that was quite amazing. And so now we have more than 700. And we started studying them in the laboratory using a mass spectrometer to figure out what these spherules are made of. And of course, we went also to regions that are far away from the meteor path so we can see the background and compare what lies close to the meteor path relative to the background. That's necessary, because anything within the meteor path is a mix of the background plus whatever the meteor left. And we found a concentration of spherules. There was a higher yield of spherules per unit mass retrieved of the background along the path of the meteor. So that was important because we realized we are in the right place. We find it along the meteor path. But then when we study the composition, we are now able to demonstrate whether the material is indeed from outside the solar system, because the abundances of elements are unlike anything you find in the solar system, not what you find on Earth, not on the moon, not on Mars. And so completely independently of the speed of the object that initially was used to trigger my interest in it being interstellar, there is independent evidence from the composition. And the paper that we are about to submit includes all the details. And moreover, we, aside from elements in the periodic table that have very different abundances, we also have isotopes of iron, for example, that have different abundance ratios. And you just realize the solar system was made out of a cloud of gas that was enriched with heavy elements from an exploding star nearby. And the entire solar system started with the same abundance of elements. If an object comes from far away, it came from a region that was near a different star that exploded with different abundance pattern. And moreover, if it's artificial in origin, obviously, if you think about melting semiconductors or melting computer screens, you will get a very different abundance of rare elements. So the first question that we are addressing is whether the material is from outside the solar system. And by the way, that's historic, because it's the first time that humans put their hands on materials from a big object that came from outside the solar system for the first time. Only over the past decade, we discovered objects from outside the solar system. That's amazing. And the first one was this meteor. And so the second question is, of course, is it a technological gadget? And the simplest way to tell is if you find a big piece of the object on the ocean floor. The technique we used with magnets is not able to do that. We need to go back again to look for a big piece of the object, because if it's a technological gadget, obviously it's different from a rock. It will have some buttons on it or screws. And in the last class of the spring semester that I taught at Harvard University, I asked the students, if we do find a gadget and it has buttons on it, should we press a button? And half of the class said, no way, don't do that, because it would risk all of us. And the other half said, of course, we would like to know what it will do. Mm-hmm. And then one of the students asked me, and what would you actually do, Professor Loeb? And I said, I would bring it to a laboratory and examine it before engaging with it.
Fair enough. I would just press the button if it was me. I'm just too curious. Like, there's a chance it'll blow up, but like, what's life without taking a little risk?
That's right. I mean, we die anyway, so why not have it in some fireworks?
Exactly. And that's how, like, humans have evolved over time. We like to like prod and touch and like explore the space around us, like you're doing.
Yeah, so your approach is similar to a kid, and that's exactly where I come from. I maintain my childhood curiosity. When I went on the jet that took us to the Pacific Ocean, I was greeted by the pilot. As I walked up the stairs, he said, "Welcome aboard, Professor Loeb." He knew who I am. And I said, you shouldn't use titles with me. Just call me Api, because I'm a curious farm boy. That's who I am. Fundamentally, I didn't change much.
True. I mean, I guess we are all at the core, like still little kids, and then we pretend to be like, all our like degrees and our professional experience. But then if we let the child inside us, like, just be free, I think we'll be a lot more happier people.
Exactly. When I was a kid, the most traumatic experience I had was sitting at the dinner table and asking a difficult question. And the adults in the room would pretend either they know the answer or would dismiss the question simply because they had no clue. And I hated that experience. It was very troubling to me that people are trying to put makeup and pretending to be something else more than they actually are, showing off. And I thought that by becoming a scientist, I can be sincere and, learn by myself, just the way kids do. That if there is an object at a distance, they go there and start turning it around, figuring it out. Whereas the adults look at it from a distance and say, I pretty much know what it is. I will not waste my time and energy going to check it. And that is the biggest mistake, because you never learn something new this way. And in fact, with the expedition, on the day that I came back, there was a paper published in the Astrophysical Journal by people who specialize in rocks in space. And they said, we use a model for space rocks. We cannot fit the data from the US government, and therefore the data must be wrong. The speed is actually 3 times slower, and then it fits our model for a stone. And it's not an iron meteorite, it's actually a stony meteorite. And at the time that this paper appeared, I held in my hands the spherules from the location of the meteor. And I knew that most of the composition is that of iron. And so it just shows you that, the experts very often resist new knowledge. They insist that the data, very arrogantly, the data must be wrong. By the way, in this case, the data was collected by the US Space Command. That's the organization that gets more budget, more funding than NASA. And they are searching Earth for any national security threats. So if they were wrong by a factor of 3, I would not sleep well at night, and just for astronomers to claim that in order for their model for stones to fit the data is really, I think, very arrogant. And I call that the stone age of science, basically. Everything in the sky is stone.
Speaking of people pushing back or like just disagreeing with the data, the findings, or like changing the data just so that it's convenient for them. This is a conversation we had before as well. Now that you've gone and like found these elements and on not elements, these objects that is clearly not of human origin or natural origin on Earth. First of all, has there been pushback, and what's the the gossip in the space right now?
Well, so the paper is supposed to come out soon, within a week or so, and we shall see what people say. But I take the approach of the eagle. The eagle sometimes has on his back the crow, because the crow is the only bird that can ride on the eagle's back and peck on the eagle's neck. And the eagle, instead of fighting off the crow, just rises to greater heights where the oxygen level is low, so that the crow just cannot survive there and drops off the eagle's back. And so for me, going to greater heights is actually practicing science to the best of my ability, collecting the materials from this meteor, studying it in the laboratory with the best mass spectrometer. And my hope is that with clear data, all the crows that are pecking on my neck will drop off. That will be the highest level that I can get to. I haven't yet seen their reaction, but that's my hope.
You're also in the process of almost getting your book published right now. It's be coming out. It also touches upon these topics, so it's gonna, like, ruffle a few feathers. People are going to be talking about Interstellar. When is it out? Can you tell us a little bit brief, or like what made you want to write this book?
Yeah, so the book is called Interstellar. It's coming out on August 29th, 2023, very soon. And it's about the impact that finding a partner in among the stars will have on humanity. Even just the search should have a big impact, just like preparing for a date. And the way I think of it is, Enrico Fermi, the famous physicist, back 72 years ago, he had lunch at Los Alamos, and he asked if extraterrestrial intelligence is so likely, where is everybody? And that is similar to a single person staying at home and saying, I don't see any partner around me. Well, to find a partner, you really need to go out to dating sites. You at least need to look through your window or to go out to your backyard to see if there are any objects that may have arrived from your environment. But we didn't do any of that. Enrico Fermi didn't look through a telescope. And only over the past decade, we were able to find objects as big as a football field from the reflection of sunlight within the orbit of the Earth around the sun. Oumuamua back in 2017 was the first one recognized. And then this meteor from 2014, almost a decade ago, is the first object that was recognized from outside the solar system. So it's really not up to Enrico Fermi to ask where is everybody, when we only recently were able to see objects, that came from outside the solar system. And of course, people try to get radio signals from outer space, and assuming that they use the radio for communication the same way that we did a century ago. By now, we are not just using radio. And so that is just like waiting for a phone call. At home, you need the counterpart to be active when you are waiting. And if they sent a signal a billion years from now it's at the edge of the universe, a billion light years away. So it's not really a good idea, because then you have to really listen at the right time. And most of the time there may be silence, because most of the civilizations that preceded us are dead by now. I mean, we will be dead in a billion years, because the sun will boil off all the oceans on Earth. So life as we know it would not exist on Earth. So therefore, a much better approach is looking for any relics that were left behind civilizations. And if you find a package in your backyard, you don't need the sender to be alive. The thing about these rockets that we launched is, first of all, they move at a speed that is 10 times slower than the escape speed from the Milky Way galaxy. So they keep accumulating over time. They can't escape the pull of gravity of the Milky Way. And it's just like plastics in the ocean. You keep accumulating space trash, and most of them might be not functional anymore after such a long time. And they would appear as space trash and collide with our planet and appear as meteors, interstellar meteors of some unusual material strength and speed, just like this interstellar meteor that I described. But others may be functional, and we might notice visits. So we are just at the beginning of this path of searching for packages in our mailbox and near our doorstep. And since it's a path that was not taken before, there is a chance for low-hanging fruit, that we will discover something nobody else realized before. So that's why I'm so excited about it. And the implications for humanity would be huge. And that's what I describe in my book. It will change our perspective about our place in the universe. We will realize that we are all in the same boat, the Earth that is sailing through space. Just realizing we have a neighbor may bring us together, because when I was on a boat with all the team members, each of them worked selflessly for the success of the mission. And I hope the same sense of working together would apply when we realize that we are all members, equal members of the human species when we realize we have a neighbor.
That is a perfect segue for my next question: human species, and then how we approach like space exploration. Because right now it almost is a competitive race where like each country is like, even if we have our findings, we want to keep it very private. Because again, whatever competitive edge we have, it works in our favor because it's all very political.
Right.
How do you suggest? Like, what are your recommendations?
Right. So this is the past history of humans. It was driven by our ancient history of zero-sum games. When we were in the jungle, there were limited resources. So if someone gets a banana, another doesn't have that banana, and so it's limited. What we have now is a abundance of products made possible by technology and science. And science is an infinite sum game. It's not a zero-sum game. So by working together, by sharing knowledge through the scientific method, we can all benefit, and there is no limit to how much we can benefit. Just think about the latest technology of artificial intelligence, AI, that could potentially, relieve us from a lot of jobs that are quite boring, to say the least. And then these AI systems will do them better than humans. And also robots might replace construction workers. So in principle, our quality of life will improve because we will not have to do these hard jobs and boring jobs. We will have much more free time. And it just illustrates the idea that with science and technology, everyone benefits. That it's not as if by developing science, whoever develops it is taking away something from someone else, because we learn something about the reality through the method of science, and using that knowledge, we can adapt to it in ways that are much more efficient than if we didn't know that. That's the whole idea. And so my point is that if we decided to stop engaging in these zero-sum games, for example, wars, the war in Ukraine, where, if Russia takes a piece of territory, Ukraine loses it. But actually, if you look at it from space, from a spacecraft, you can't even notice the border between Russia and Ukraine. It looks completely meaningless to fight over a piece of land on this two-dimensional surface of Earth, the rock that we were born on. And we are spending $2 trillion every year on military budgets worldwide, meaning on the effort either to kill others or to protect yourself from being killed, which is a complete waste of resources. Because if we decided that our biggest priority is exploring space, for example, just trying to figure out how to move into space, then with $2 trillion a year, we could send a probe towards every star in the Milky Way galaxy, billions of them, within the coming century. Within 1 century, we can do that. So just think about changing priorities can mean so much for the prosperity of the human species, for our ability to survive long term. And so it's all about collaboration and showing that we are more intelligent than animals. Most of our history, we behaved just like animals. And from a distance, I'm sure any extraterrestrial civilization would think that, there is not much intelligence there on Earth. It doesn't look very different from the behavior of animals. But the one signature of intelligence is the ability to develop science and technology and evolve to an abundance economy where everyone benefits, and it's not about zero-sum games. And that has to do with working together. And my hope is that we will get a wake-up call from meeting some packages that were sent by a more advanced civilization to behave better. That's my hope, and that's what I discuss in my book.
What about I know this is specific to like space exploration and extraterrestrial life, but is there an example that you can give, or like you have seen throughout the scientific community, which has been this has become more collaborative versus like it's competitive?
Yeah, definitely. Much of science is like that. Well, there is competition because obviously whoever finds something new gets recognition and rewards. So in that sense, there is a prize to be given to whoever discovers new knowledge. So in that sense, there is competition. But as long as it's targeting the goal, as long as our eyes are on the ball of understanding reality rather than showing off, that's a very productive endeavor. However, in academia right now, a lot of the activity is driven by showing off, demonstrating that one is smart. And that includes the interactions among colleagues, that sometimes people work with. For example, in the mainstream of physics, there is a lot of discussion for several decades now about extra dimensions, extra spatial dimensions. We don't have any evidence for that. And there are, hundreds, if not thousands, of very talented mathematical physicists writing lots of papers about the implications of extra dimensions in terms of unifying quantum mechanics and gravity, the two pillars of physics. But we have no clue that this is relevant to reality because we haven't seen any evidence for an extra dimension. And moreover, we don't expect to see such evidence in our lifetime. And so you ask yourself, why is such a large community of people defines this as the mainstream if there is no evidence for it, if it could be just a fabricated story that has nothing to do with reality? And the answer is because it gives people a sandbox to demonstrate how able they are mathematically. They can do mathematical gymnastics and show that they are smart. And that is sufficient in academia in order to get promoted, to get awards. You just show your peers that you are smart, and if a big enough community advocates for this theoretical speculation, then it becomes mainstream. And it was interesting because one of the foundations of this was supersymmetry, a new symmetry of nature. And a lot of people said, oh, that will be tested with the Large Hadron Collider. And there were $10 billion invested in the Large Hadron Collider. And one of the highlights was supposed to be the discovery of supersymmetry, which is the foundation of string theory. And then they did the experiment and they didn't find anything. There was no evidence for supersymmetry. And I actually met for lunch one of the leaders of string theory just half a year ago. And I asked him, what is your main scientific paper accomplishment? What is the paper that you're most proud of? And he said, it's a paper about supersymmetry. And I said, but actually, as you know, supersymmetry was not demonstrated to be real so far. And from his perspective, it's not a problem because it may be just around the corner. The next accelerator may find it. And it reminds me of, there is a religious Jewish community in Crown Heights in Brooklyn, and they thought that their rabbi is the Messiah. Okay, so they prepared for the rabbi. So in fact, they built an apartment. The belief is that when the Messiah arrives, he goes to Israel, okay, and lives there. And so they built an apartment for him in Israel that is a replica of his apartment in Brooklyn, so that he will find the toilets quite easily when he becomes the Messiah. And then he died, and they were expecting him to come back as the Messiah. That was the theory, just like in the case of supersymmetry. Everyone said, yeah, that should be the case. And there was a huge community believing in it. But then he didn't show up as the Messiah. So what did they say? The explanation was, we just have to wait. It will, he will eventually come back. Okay. And I ask, what's the difference between a religious belief of this nature and those scientists who believe in string theory, in supersymmetry? It's just around the corner always. The difference is, obviously that science is supposed to be faced with experimental data, because there is this guillotine that decides whether an idea is correct or not. And even if it's beautiful, it doesn't mean that it represents reality. And when I work, for example, on objects that look anomalous, it's all driven by evidence, okay? And that's why I went to the Pacific Ocean to collect the evidence. I'm trying to do science in the traditional way. And somehow what I'm doing appears to be controversial. That's what I find strange, because I'm following the practice of science where you collect evidence, try to test your ideas. And at the same time, you have speculations being promoted by mainstream in physics for 4 decades without any evidence.
Speaking of religion, how might the discovery of extraterrestrial intelligence impact religious beliefs then and traditions?
Oh, that's a very interesting question. Well, both the frontiers of science and spirituality share one thing in common, which is exploring the unknown. And the difference between them is that in the religious context, what you adapt follows your beliefs, and it's individual to each person. Whereas in the context of science, it's supposed to represent reality. So it's guided by evidence, which can be shared by everyone, and all scientists, once they see good enough evidence, should be able to agree. So it's not a matter of belief, it's more about a matter of the evidence that is collected by instruments, not by people telling you what they think. So there is a difference in the method, but just imagine an encounter with a very advanced civilization, some gadget. It would look like it's doing miracles to us, because think about a cave dweller coming to New York City. All the technological gadgets that the cave dweller would witness would appear as miracles. He would be filled with awe and come back to his family and report back that he experienced some religious miracles. And my point is that a very advanced technological civilization relative to us would appear to us like God, in the sense that it would be able to produce things that we've never imagined, that our technologies cannot reproduce. It's well beyond what we expect, and it would look like miracles. And that includes even producing life, or maybe even producing baby universes. If they know how to unify quantum mechanics and gravity, they might produce baby universes. And these are qualities we assigned to God. I mean, superhuman ability. So altogether, the interaction with a much higher level of technology could resemble the awe-inspiring experience of a religious person. And to me, that represents a way of bringing religion and science together, because in this case, you will encounter something that is really not understood for us, but it's actually real. You see it, you can measure it with your instruments, you can use video cameras to monitor it, you can measure the properties of the object using the instruments we have. So it will be something in reality that our instruments can record, not an individual belief system or experience that is unique to an individual, but an experience that can be recorded by our instruments, okay? And in that sense, it can be shared by everyone, and everyone would be able to realize that it's real. But it would represent something beyond our understanding. And I think that is our future. Once we encounter, that will be a religious experience for us.
Speaking of religious experiences and somewhat like tied in with mysteries, what are some scientific mysteries and questions that you believe would be addressed encountering technologically advanced extraterrestrial beings?
That's an excellent question. You ask very good questions. So another way to phrase it is, if I had a set of questions that I would like to ask a more advanced scientific civilization, what would it be? And obviously, the first question is, what was there before the Big Bang? Because we know that our universe, if we go back in time, started from a point in time when the density of matter was infinite. And we can't go beyond that because Einstein's theory of gravity breaks down. We know why it breaks down, because it's not unified with quantum mechanics. We don't have a predictive theory that unifies the two, that would tell us what happened before the Big Bang. So as of now, it's a singularity. You go back to that point in time and you don't know what happened before. And perhaps a more advanced scientific civilization would know the answer. And the reason I'm curious about it, because it represents our cosmic roots. If we want to understand where we came from, that's a very important question. And moreover, it represents any understanding that they might have of how to unify quantum mechanics and gravity, a very important scientific milestone. Moreover, it may be possible to create a universe, a baby universe in the laboratory once you understand that, by engineering the conditions to do that. And it may well be that our Big Bang was created in the laboratory of an advanced civilization with scientists in white lab coats. And it's the way to think of this is just like generations of people where babies grow up to become adults that make babies and so forth. So if you create a universe that is similar to yours, where new scientists are able to make new universes, so that's a recipe for getting babies inside of other babies and so forth. And so it may explain how the Big Bang started. I would like to know that. But there are many other questions that we don't know the answer to. In fact, we're very ignorant, despite what some scientists pretend to show. We don't know what most of the matter in the universe is. 83% of it is called dark matter. It just doesn't interact with light, so we can't figure out what it is for, almost 90 years now. And the question is, what is the substance that makes it? And perhaps if we understand that, we can use that substance for something. So that's another question that I would like to ask. And then what happens in the inside of black holes? When matter falls in, where does it go? Does it make a very compact object in the middle of the black hole? We don't know that. And so I would like to understand that. And there are many more. For example, the most interesting question, actually, that is quite relevant, is how many other neighbors are out there, like us, that are intelligent, and when is the next party in our block that we can go to and meet them?
Speaking of, the next party across the block, you have you have the Galileo Project, and you had selected a specific space for the observatory. Why was this selected? What contributed to you making those decisions, and why and where?
Yeah, so about 2 years ago, we announced the Galileo Project, and that I'm leading, and the idea was threefold. The one is to look for more objects like Oumuamua that I mentioned, that pass near the Earth. Next year, there will be a new survey telescope called the Rubin Observatory in Chile that will be much more capable than the one that discovered Oumuamua in Hawaii, Pan-STARRS. And the idea is to monitor any object that it looks as if it's moving too fast to be bound to the sun, any interstellar object, and get much more information about it so we can tell if it's natural or technologically manufactured. In the case of Oumuamua, it was not obvious, and the possible technological origin came from the anomalies that this object exhibited. So we would like to know more about similar objects. And then the second branch is to do expeditions of the type that I described, to go after interstellar meteors and figure out whether any of them was technological, a spacecraft. And the third branch is to look for any functional devices near Earth. And these are called unidentified anomalous phenomena by the US military, by the US intelligence agencies, UAP, unidentified anomalous phenomena. There were 2 reports delivered to the US Congress by the Director of National Intelligence, where she was mentioning hundreds of reports from military personnel that see or encounter some unusual objects. They can't figure out what they are. Most of them are probably balloons or drones, but a small fraction is completely unidentified. And the question is, could it be extraterrestrial? Because some of those behave in ways that one cannot easily understand. And so we established an observatory at Harvard University. We now put it in a different location than we initially put it on. So it's a remote location on Harvard University property that allows us to monitor the sky 24/7 all the time in the infrared, optical, radio, and audio, and use machine learning software to figure out whether we are looking at a drone, balloon, maybe a bird, or airplane, and see if there is even one out of 1,000 objects that may be completely strange, unfamiliar, perhaps not from this Earth. And so we have one observatory operating, but we want to make copies of it. And we are already in advanced stages of making the second copy. And then we hope to make more, up to tens of copies placed in different locations to get to the bottom of these UAP and figure out what they are.
How does the Galileo project work align with NASA's Confidence of Life detection scale? What significance does the alignment hold in potential extraterrestrial discoveries?
Yeah, that's again an excellent question. And a month before the Galileo project was conceived, I approached NASA and asked them whether they might be interested in establishing an effort of this type. And I submitted a white paper and haven't heard back. And then a year later, they established a study that is supposed to deliver the report actually very soon, by the end of August 2023. And this report will tell NASA whether to invest funds in research related to UAP. But we are already doing it within the Galileo project. It would be nice if NASA funds such efforts. We could then apply for some funding. But at the moment, we are supported by donations. And I look forward to seeing what the report says. My guess is that it would say exactly the same things as the Galileo project is saying, which is to get more confidence in the nature of these UAP, one needs a systematic study of the sky using instruments that are well calibrated and under control. Because all the reports from the past were anecdotal. Some pilots happened to be at the right place at the right time and they saw something unusual. But without having a systematic study of the sky, you don't know what is the background, how many objects pop up that you might mistake for something unusual. And so just the only way to get a better knowledge of the noise before you decide that you're seeing a signal is actually by a systematic study all the time and then seeing whether you are noticing anything unusual.
Like you said, like the Galileo project focuses on data accumulation and the classification of unexplained phenomenon. How does this approach contribute to the understanding of UAPs and the potential extraterrestrial civilizations?
Right. So we want to figure out any object that might be from this Earth, and that includes birds and human-made objects. And the way to do that is by training a machine learning software to identify, it's not a trivial matter because, for example, if you imagine an airplane, you can see the airplane from different angles. It would look different. You can also see different times of the day. So the reflection of sunlight would appear different. And it could be different types of airplanes. So you need to train your software on many, many different possibilities, on a huge library, even for one airplane. And then, moreover, you need to imagine all possible objects, including drones, balloons. And the question is whether anything behaves in ways that are anomalous. And the definition of that is that it doesn't look familiar, that, for example, the object maneuvers in ways that you cannot reproduce with existing technologies. And for that, you need to know the distance, because otherwise you see it moving on the sky. But if it's very far away, it would move extremely fast. If it's very close to you, it doesn't need to move very fast. It could be a fly. So to detect the distance, you really need to do what is called triangulation, where you have multiple sensors looking at the same object from different directions. That's why we have two eyes. Animals that had one eye did not survive in the jungle because they couldn't figure out the distance of the threat. When a lion would come to them, they would think, oh, maybe the lion is very far away, but it was actually close. But with two eyes, you can tell the distance. That's the whole point, because they see the object from different directions. So triangulation and measuring the distance is key. And of course, that means that you need multiple sensors at different locations looking at the same object.
What are the technical and ethical challenges associated with the concept of intercepting and studying interstellar objects?
Okay. Yeah. Well, first, there is the issue of you don't want to interfere with military activity or with national security issues. So you don't want to put the system near sensitive sites, okay? And the other thing is, of course, you don't want to invade privacy of people. So going to remote locations sounds ideal, where you reduce also the level of noise, where there aren't as many things in the sky. I mean, the worst place is a military zone where there are lots of things in the sky, bullets, artillery shells, drones, and you just don't want to be there, not only because of the risk, but also because the noise level is so high that you may mistake, you may not figure out some objects that are out there, and their nature is classified. And also when you record these objects, you might get into trouble. And so we obviously try to avoid that.
Speaking of rendering of the seismometers capturing IM1's impact related to the dawn of the interstellar future, what does that look like? What is the implication of it all?
Right. So this interstellar meteor that I described from 2014, I called it IM1, Interstellar Meteor 1, which, by the way, also means I am one out of a population. So this is the first interstellar meteor. In fact, if you assume that it was just on a random trajectory, there should be millions of such objects within the orbit of the Earth around the Sun, because the Earth has a very small cross-sectional area to collide with one of them once per decade. So at any event, the idea is that by understanding what IM1, this first interstellar meteor, is made of, we can also go back in time and look at historic meteorites that were collected on Earth and see if any of them shares the qualities of IM1. So that allows us to open up a new line of investigation. Maybe such objects existed already and collided with Earth in the past. We just didn't record their velocity before impact, so we didn't know that they came from interstellar space. But now we may have the fingerprints of any object that came from interstellar space, so we can check for that. And I should say it's a new type of astronomy, because we are used to using telescopes to look for what lies outside the solar system. And in this case, we were using microscopes to look at these spherules, the tiny droplets, to learn what lies outside the solar system. So it's a completely new way, in a way pioneering a new frontier. And my hope is that we will find more objects like that, more interstellar meteors, and we can check how many of them are of technological origin. And perhaps we'll be surprised. And obviously, a meteor is an object that is not functional, because it just collides with Earth without maneuvering, But this is what would happen to our spacecraft, the ones that we launched to space. We launched 5 interstellar probes, Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons. And they were launched over the past half century, and they will exit the solar system in 10,000 years. And at that point, they will not be functional anymore.
Can you elaborate on the potential challenges and opportunities of expanding human presence beyond Earth, or how might this endeavor affect the unity of the cooperation of us as a global society? You kind of touched upon the fact that this will make us a little bit more not us versus them, but then us together, exploring the space. But then what are the other challenges that we might have to face?
Right. So irrespective of what we do about global warming, our planet will burn up in 1 billion years, because the sun will brighten up and all oceans will be boiled off. So life as we know it will not exist in 1 billion years. That's 20% of the age of the Earth. So, we lived through 80% of the history of Earth where life was possible, and we don't have much left, only 1/5 of that history. And after that, we'll have to go somewhere else. So, of course, if you think about the Earth, we are at the right distance from the furnace, from the sun right now, but the furnace will get hotter and we won't be able to adjust our distance so that we would feel comfortable. And so a simple solution to that would be to have a space station that can adapt to the changing sun and move farther away when the sun becomes brighter. Another approach would be, instead of using the sun to warm us up, creating our own sun. It's nuclear energy. We know how to harness it in nuclear reactors. And we could imagine going anywhere with our own energy supply, nuclear energy supply, on that space station. But at any event, we will have to come up with a solution to transport people, anything, any forms of life that we want. And the way I think of this is like Noah's Ark, the biblical story about Noah saving life forms on Earth from the giant flood that was threatening. And he basically put them on a boat. But here it's a spaceship. So I call it Noah's spaceship. But the longer term, in the very long term, I think that we might want to send out gadgets that have their own brain, artificial intelligence, because the distances between stars are so vast that no human can survive that unharmed, and because of the hazardous conditions and cosmic rays bombarding the human body, and also the duration of the journey is extremely long. But we can send systems with artificial intelligence that are autonomous. They make their own decisions without waiting for guidance, because even the guidance will take a long time to reach them, thousands of years across the Milky Way galaxy at the speed of light. So that means that they will be independent, and they could go places and use the raw materials on other planets to recreate life as we know it, instead of carrying the life in a spacecraft, which is a much less efficient way. And actually, if you think about it, nature did that, because the dandelion flower is sending dandelion seeds in the wind, and they carry the DNA of the flower, so that wherever they land, they create new flowers. You don't carry the entire flower in the seed. You just carry the code that allows you to generate it again. And nature came up with this solution. There is no umbilical cord connecting the seeds to the flower, no guidance being sent by the flower to the seeds. They just do their job after being carried by the wind. And we can adopt the same approach, where we send these systems that have their own artificial intelligence, maybe 3D printers. They go places and they can reconstruct life by using the raw materials there, instead of carrying it from Earth.
You have, in your work, there's been a lot of emphasis on the importance of understanding and seeking intelligence in extraterrestrial life. What key markers would you say are markers for intelligence, and then how does that translate with societies and individuals who pursue wisdom, along with acquisition of knowledge?
So I think our future will be very different than our past. And that means that when we encounter something more sophisticated than us, it would look very different from our past societies. And the reason I say that is because artificial intelligence is transforming society as we speak. It's growing exponentially in its capabilities over a few-year timescale. So if you imagine what the world would look like 100 years from now, it will be extremely different than what it used to be like, because artificial intelligence will change the way society is constructed. The interactions with AI systems that are superior to us, perhaps in their abilities, would require new legal system, new societal infrastructure. And in that sense, it's quite possible that our future is more about AI systems than about biological humans. It's not yet, it's to be determined. But if that's the case, it means that when we encounter, our replicas from far away that preceded us, they are already living that future. And therefore, we would notice that indeed we are not encountering biological creatures, but any functioning devices are mostly about AI astronauts. And that would be fascinating to watch.
Okay, connecting this with sustainability and then nature itself, how does how does it relate to the current focus on sustainability and technological
Okay,
advancement?
so sustainability and the current plans that we have are, incremental, extrapolating from the trends that we have based on what happened recently, and what I'm talking about is timescales much longer than the next decade and the next 2 decades. And
Hmm.
on those timescales, I think there would be transformative changes driven by AI, driven
Hmm.
by exploration of space. Now, one way to get a glimpse at where we are heading is to see someone that went through these changes already, our neighbors, if they
Hmm.
are out there. So I'm proposing a shortcut that will give us a sense of where we're heading. But you are right that as of now, we are usually planning a decade, 2 decades, maybe 3 decades ahead of time. And we're thinking about mitigating the risks within that period of time, which is related to sustainability and these considerations. But when there are transformative events that change everything altogether over a century, it would be very difficult for us to extrapolate, because it will be a reality that is so different than what we have right now that we can't really apply the same tools.
What are the drawbacks of using AI, almost like robotic avatars for space exploration, particularly in the focus of autonomy and adaptability in extreme environments?
Well, it's just like raising kids, and you ask, okay, what are the risks? The risk is that the kid will, at some point, once the kid becomes an adult, independent, will decide to go in a completely different direction than you wanted that kid to go in. And so, when you send autonomous systems, you face the risk that they will, quote unquote, misbehave. They will do things that you didn't wish them to do. That's always a risk that comes together with autonomy, and we have to take that risk and mitigate it as much as we can by giving training those systems on principles that we believe in, just like educating kids. You want to prepare them using the same guiding principles as we have, and that is called alignment with our goals, and also equip them with the tools that would allow them to pursue those goals in the best way under changing circumstances. So the way I see it is very similar to the way of raising kids and educating kids so that they would become responsible adults.
In the pursuit of scientific advancement and space exploration, how can we effectively balance the potential benefits with the existential risks posed for our own planet? What strategic, suggestions would you employ to ensure our progress is contributed positively to our civilization while minimizing the negative consequences?
Right. So as of now, if you look at space explorations, they're driven mainly by commercial benefits. For example, putting communication satellites. That's a financial interest to make money. Then there is obviously also a space race related to national security, where nations are putting satellites that are used for espionage and communication and technological superiority, and that is a main factor in the space race. It was the reason that there was a space race since the 60s between Soviet Union and the United States. And finally, there is this sense of national pride. In addition to the military benefit and the commercial benefit, nations race to space just to demonstrate that they are superior relative to other nations, or at least they enter the club of other nations that go to space. And that again has to do with showing off. I think all of these are guided by the same motivation that we discussed before of zero-sum games and comparing yourself to your counterparts and trying to do better than they do just so that you are superior to them. And the true motivation for space should be that of curiosity, because there is so much real estate out there and so much that we don't know. For example, on Mars, we know that there are caves there, the lava tubes, and my curiosity is to figure out whether, if we go into those caves on Mars, whether there is any relic of life that existed on early Mars. And I would like to know, for example, if there are any wall paintings, prehistoric wall paintings in those caves that represented early creatures that existed on Mars when it had an atmosphere, when it had liquid water on the surface. We haven't done that. We haven't gone there in that way. And NASA sent the Perseverance and Ingenuity, but they are studying incremental questions that are not really transformative. And for example, I would much rather have NASA put a drop of water into the Martian soil and check whether anything wakes up there, any form of life. They don't do that. Or go into those caves and figure out if there are any relics that were preserved, because the surface of Mars, on the equator, changes temperature by hundreds of degrees between day and night, and it's bombarded by micrometeorites and cosmic rays. So it's hard to imagine life surviving on the surface, but underneath, in those caves, you might find some interesting things. And also in the ice, the frozen water ice on Mars might also have some life forms in it.
Can you explain the process of cosmic gamma rays being absorbed by interactions with solar photons? What are the implications of this absorption for astronomical observations?
Right. So this is sort of an exotic phenomenon where light can interact with light. It's a prediction of the quantum theory of electromagnetism, where we are used to light just passing through space, but in principle, light at sufficiently high energies can produce particles by colliding with another form of light. And in this case, it's a very energetic particles of light, photons, that collide with the light that is produced by the sun. And that can produce electron-positron pairs. And I did a simple calculation that shows that actually the chance of that happening is 7%. It's significant near the edge of the sun. And that means that, it's interesting to check if there are pairs being produced there. It doesn't change what we do in astronomy, because far away from the sun, the chance of a collision is not very great. It's only close to the surface of the sun where the density of photons, of the particles of light, is high enough for this to be important. So it's just an interesting physical effect that nobody thought about. I thought about it during the pandemic and wrote a scientific paper that can be tested, by checking for the signatures of pairs, electron-positron pairs, near the surface of the sun.
And then what is dark matter, and how does it dominate the mass budget of the universe? What evidence supports the existence of dark matter?
Right. So we have various ways of measuring the amount of matter in space. And one of them is using the law of gravity. So, if we see, for example, we see the planets moving around the sun. So from the speed of a planet like the Earth and the distance from the sun, we can figure out the mass of the sun required to gravitationally bind it. And in the same way, you can calculate the amount of mass needed to bind stars to a galaxy, because you see the stars circling the center of the galaxy, and you can tell how much mass there is interior to their orbit. And when this is done, the interiors of galaxies can be explained in terms of the mass there. It's just the mass that we see in the form of stars, in the form of gas, ordinary matter. But when you start going to the periphery, of galaxies, it looks like there is not enough mass in ordinary matter, in stars and gas. So there must be some other form of matter that enhances gravity, and that is called dark matter. And the evidence for it comes also from the universe at large, because we can see the rate by which the universe expands, and from that infer how much mass there is inside of it. Um, and, um, and that leads to dark matter with the same quantity. So now we are faced with the question of what is it, because we can't see it, doesn't interact with light, and we haven't witnessed it in the solar system. So by the way, the breaking news is that not everything in the sky is made of stones, the way that these astronomers were talking about, because we know that there is dark matter. We haven't seen it in our solar system, and it exists, and it's not made of stones. Okay, so I hope they would realize that when they write papers that say the data must be wrong because it doesn't fit a model of stones. Because in the case of dark matter, they would argue that dark matter doesn't exist, the data about it is wrong. But in fact, there is so much data that proves the existence of dark matter that it cannot be wrong. What is it is an unsolved puzzle. We don't know. It could be a particle that is not recognized as of yet, but interacts very weakly with light. And the type of the particle is not known, so we are still searching.
It's a big question mark for
Right.
now.
Yes.
What is the Hawking's limit, and why is it significant in relation to human potential and achievement?
Right. So you can ask what defines humans. And of course, we are thinking not just about a mental picture, but also physical image of a human when we interact with each other. And what Hawking demonstrated is that his body was not really essential except for his brain. You know, like at some point he couldn't move a single muscle, and nevertheless he was able to behave just like a human. He expressed himself through this machine that translated the motion of his eyebrows into words, and so you know, that's the limit by which the body is not so essential, that there is something deeper than that that defines a human, and it has more to do with the brain than anything else. And so that's what I call the Hawking limit. Stephen Hawking actually visited my home back in April 2016. I had a chance to interact with him. He was full of life, enjoyed life to the fullest, and was not depressed at all by the fact that his body could not move. He even had an affair with his nurse at some point.
Okay, let's switch gears a bit. What is the concept of self-interacting dark matter, and how might it lead to the existence of dark atoms, dark stars, and potentially life as we know it?
Right. So we know that the dark matter does not interact with light or with ordinary matter. We can't detect it easily, but it could interact with itself. So it could be like a parallel form of matter. Just like the ordinary matter interacts with itself, there is this other sector of particles that interact with each other, but not with ordinary matter. And this is a possibility. And then that kind of dark matter could make its own atoms and its own stars in principle, but we can't see them. And we would just detect their gravity, the gravitational effect that they have.
Would that be a possible argument for an alternative reality, like, you know, the different dimensions that are there, and this like dark matter is almost like a portal to it, and we just have no access, and that is the reason why we just don't know it?
It could be, since we don't know the nature of dark matter, we can't tell, but it could also be another sector of particles that, you know, have their own interactions among themselves, that you know, have their own world, so to speak. And of course, we would never see those if they don't interact with ordinary matter.
What challenges and potential breakthroughs are associated with the James Webb Telescope and the Vera C. Rubin Observatory and projects like the Galileo Project? How might the advancement of our understanding of the universe, like how does that, like, you know, enhance the whole thing?
Right. So each of these observatories has different potential. So the
Mhm.
Webb telescope looks at the infrared, and it can see the most distant stars and galaxies in the universe. And that was the reason it was constructed. I was on the advisory board for the design of this telescope in 1995 when it was first conceived. And the reason was that I worked back then on the first stars and galaxies in the universe, and that's the way to look for them. And it already found the deepest images of those galaxies that show some puzzles. For example, we see many more massive galaxies than we expected. And the question is why? What goes wrong with the standard model? I wrote two textbooks on the first galaxies, the first stars. And the one thing I always said is that I would be glad if the observations do not agree with the expectations, because then you learn something new. And I will be glad to revise the content of my books to accommodate these changes. But so far, the Webb telescope shows many more bright galaxies when the universe was less than about 500 million years old. And we don't know why as of yet. And that remains to be seen, but it's work in progress. The deepest images of the Webb telescope were celebrated in the White House on July 12th, 2022. And that was a major milestone. So that is the importance of the Webb telescope. And also it looks at the exoplanets and can tell us about their atmospheres, things that we didn't know before. And of course, if there is another object like Oumuamua, and we look at it with a Webb telescope, it's just another eye that looks at that object 1 million miles away from Earth, 1.5 million kilometers. And if we have an observatory on Earth and the Webb telescope looking at the same object, we can figure out its distance very precisely and the motion of the object in 3 dimensions. And from that, tell whether it has any propulsion based on exquisite precisions in position. And another telescope that you mentioned is the Rubin Observatory, and that will survey the sky in the southern sky, every 4 days. And it will have a 3.2 billion pixel camera, so 1,000 times more pixels than a cell phone camera. And it's just a huge amount of data, and it will discover new transient sources in the sky, but also new objects like Oumuamua that I talked about. And it has a great potential. And obviously, AI would be very instrumental in cataloging the type of objects that appear in the data. The data will be public, available instantly to all scientists. So that would be a great advance. And then the Galileo project is focused on those UAP, the unidentified anomalous phenomena, and hopefully we'll see something from outside of this Earth. But until we see it, we won't know.
In advancing our knowledge of the cosmos, how do you see the balance between indirect observation and direct exploration?
Oh, I think that there is no comparison. It's just the difference between looking through your windows at your backyard and going out to your backyard. There is a big difference because you notice objects from a different direction, different angle. You see them up close. You can lift them up and check them. So direct observations, going places, or even just observing something directly rather than indirectly, has a great benefit because it offers more information. So the more information we have, the better we are equipped at figuring out the nature of whatever we're looking at. And it's all about learning what reality is like. That's all that we are trying to do, because once we understand it, we can adapt to it, we can use it. So if Galileo said the Earth moves around the sun, it's not the Earth is not at the center of the universe, it's not a philosophical argument about the importance of humans in the world. It's more about the fact that this body, this rock, is moving around the sun, and you better understand that, because if you want to reach Mars, you better know that the Earth moves around the sun, because if you send a rocket towards Mars and you have the idea that Mars orbits the Earth, it will never reach the destination. You just have a wrong idea about reality. So I see science as just a tool that allows us to learn what reality is like. And the problem is humans are always fascinated by stories, some of them fantastical, and they prefer not to check the prejudice that they have. And that's the biggest mistake we can make.
With the launch of your book, which being published for people to read, what do you hope to achieve from it? Like, what would you want the reader to take away?
I want the reader to appreciate the importance of this question of whether we have a neighbor and the implications for the future of humanity, because we need to make it part of the mainstream of science. Right now, it's pushed to the side, and one reason is the public cares a lot about it. The government now cares about it, but somehow in academia, it's being shifted to the fringes. And that's inappropriate because, after all, the science should reflect the interests of the public. And moreover, we have the tools, we have the instruments that allow us to make progress. So my hope is that in the coming years, we'll start collecting useful data and get interesting answers that would shift the conversation. And it will be a revolution, not smaller, but actually bigger than the Copernican revolution that they realized that when we realize that we are not at the center of the universe. And I think it's the biggest discovery that humanity would ever make, to realize that we are not alone.
And in terms of, like, the scientific method, also the approach to how we observe the universe, not just outside but the planet that we live in, there's loads of, like, like examples that you give in terms of, like, first of all, sustainability, the weather, technology, science. There's a message, there's an underlying message. What would that be from your perspective?
Right. So the most important part is to be modest, to feel like a student, where nature is the tutor. It's teaching us what reality is like, and we should be humble and not assume that we are superior to nature, because in fact nature is much more powerful. It's a complete illusion that we have, and obviously, we can have that illusion for a little while we are alive, but then we end up dead usually. And that even the most brilliant scientists who thought very highly of themselves do not survive that fate after 100 years typically. So the point is, nature is really much more impressive than any of us, and we should learn from it and adapt to it. Just to give you a few examples, it was only a century ago when the Wright brothers realized how to fly, and birds did that for many years before that. Also, we don't have a car that heals after it gets bumped. But if you look at the human body, when you have a scratch, the body heals very quickly. And also, we have in biology, there are self-replicating devices, that they use the background, the nutrients, and they make copies of themselves. And we just don't have, for example, a car that can replicate itself, or any machine that can make itself. Even a 3D printer cannot make itself out of raw materials right now. So we have a lot to learn. And for example, AI systems that try to replicate the human mind in some sense, they are much more cumbersome and much bigger physically, uses much more power compared to the compactness of the human brain. That's quite amazing that a system as small as our head can do so much. And I'm just at awe with nature. I mean, every morning I jog at sunrise. I really I'm an admirer of nature. And I think that the hubris we have when we develop something, technological is unwarranted, because we have a lot to learn.
And where can people find your book? Like, we can buy it on Amazon. Where else is it available?
It's available in any bookstore starting August 29th, 2023, and it's already available for pre-orders on Amazon or any other bookstore. And also, if you want to follow my research, you can check Avi Loeb at medium.com. That's where I put essays that update about my latest findings.
Perfect. Thank you so much for speaking with me.
It was a great pleasure.